This video is all about problem solving regarding Newton's laws of motion in physics. Now let's state the three Newton's laws of motion in physics. Now the first law, a body at rest will remain at rest and a body in motion will remain in motion unless it is acted upon by an external force. The second one as the force acting on an object is equal to the mass of that object times its acceleration. Our force now would be directly proportional to the product of mass and acceleration. Now, for the third law, for every action, there is an opposite or an equal and opposite reaction. Now, let's proceed with the first sample problem. Okay, this is an application of Newton's first law. So the object is in stationary position or stationary conformation. Now consider a traffic light with a mass of 15 kilograms suspended from two wires. Find the tension in each wire, and we're going to neglect or ignore the masses of the wire. Now, if we're going to calculate this problem, we're going to ignore the masses of the first and the second wires. Now, let's proceed with this solution. We are already given with a free body diagram for this problem. Okay. The force that act or that acts on the first wire, we're going to label it as tension, and this is represented as tension 1 or T1. Whereas the second wire with an angle of 45 degrees with respect to the horizontal, we're going to name the force acting on it as T2. Now, we're going to represent the weight of the traffic light as W. Now, remember, weight is calculated by the mass and gravity. Okay. So weight now is directly proportional to the mass and gravity. Now let's proceed. Now if we're going to bisect this figure and we're going to consider the first wire, it has a tension of T1 and T1x, T1y as the vertical and horizontal components respectively for the first tension. And for the second wire, it has a tension of T2. We're going to consider the horizontal and vertical components of T2 as T2x and T2y respectively. And the weight always points downwards. Now let's proceed with our free body diagram. We're going to separate these forces. For forces that points upwards or 90 degrees, these are the vertical components of first and second tensions as T1y and T2y. And vertical forces point downwards, we're going to consider it as our weight W. And for the horizontal forces towards the left as T1x and towards the right as T2x. Now, to proceed with our solution, for this type of problems, we're going to sum forces horizontally and vertically. Now, if we're going to sum the forces horizontally, forces going towards right will be positive and forces going towards left would be negative. And since our first law of motion, summation of forces would be equal to zero. Okay? In this instance, T2x minus T1x, T2x is positive because it points towards the right and minus T1x. So T1x is negative because it points towards left. And we're going to sum our forces into zero because for Newton's first law, summation of forces would be equal to zero. Now, if we further simplify this equation, we're going to transpose to the other side of the equation negative T1x, so it becomes positive T1x. Now, this forms as T1x is equal to T2x. If we further expand these formulas, we're going to consider the trigonometric horizontal components of T1 and T2. Okay, for T1x, okay, since this is adjacent to its hypotenuse T1, so the trigonometric identity we're going to use is cosine of 30 degrees is equal to T1x all over T1, or getting now T1x, T1 now multiply it with cosine 30 degrees. For the second wire, T2x is the adjacent part, since this is the horizontal component of this tension force here. T2x now is equal to T2 cosine of 45 degrees. Now, we're going to establish this as our first unknown equation. Now, the second step is to establish our summation of forces vertical components, or vertical component summation of forces would be equal to 0. Now, forces going upwards are positive and forces going downwards are negative. Now, this diagram, if we're going to focus this image, so T2y plus T1y minus W is equal to 0. Now, if we're going to consider the trigonometric vertical components of the following forces, okay, so since T2y and T1y are opposites, okay, so we're going to use sine. So for T1y, T1 sine of 30 degrees, and for T2y would be equal to T2 sine of 45 degrees. But since our weight now is equal to mass times gravity, further simplifying the equation gives us T1 sine of 30 degrees plus T2 sine of 45 degrees is equal to W, or this is also equal to mass times gravity. Okay, so this establishes as our second equation, or second unknown equation. If we solve simultaneously both of the equation, okay, this gives us to our answer for the first tension, okay, or the tension of the first wire as 108 newtons, and for the second wire as 132 newtons.